Hello, everyone. My name is Emily Kuda, and I'm Perkuna's Digital Marketing Manager. We'll begin in just a moment, but first I just want to conduct a bit of housekeeping. Can you raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me? Great. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Perkuna's database performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours or less. With that said, I'd like to thank you for attending today's webinar, Lessons from Database Failures, presented by Perkuna's Chief Evangelist, Colin Charles. Take it away, Colin.
Thank you, Emily. Can all of you hear me loud and clear? I hope that would be a yes. Okay, so I am going to talk to you today about lessons from database failures. For some reason, my mouse doesn't actually move. So, as Emily said, I am the Chief Evangelist in the CTO office of Percona. I'm very happy to be able to work with Vadim and Peter, the two founders of Percona, on a daily basis. Before this, I was on the founding team of MariaDB Server. So today, I have very simple agenda, basically. I want to focus largely on backups and the verification of backups, replication, which is just getting better, as well as failover from replication. And I want to also talk to you about security as well as encryption, which has come to the MySQL world now for a little over a year and a half. Um, I am not going to talk to you about NDB cluster. The NDB cluster or MySQL cluster is generally very highly available. It doesn't really fail. This is why it's used very actively in the telco space. I am not really going to focus on MySQL InnoDB cluster because it only recently became generally available. Instead, I will be talking still about Galera. And since we are learning from past incident reports, that's I think one of the best things one should take away is always read other people's incident reports because you can learn from other people's failures to ensure you don't make a similar mistake. So I don't know how many of you remember the site Magnolia. It was started in 2006. It focused on being open standards bookmarking service. It focused on micro formats. There was some paid components to Magnolia. And if you look at this link, you'll actually realize I've picked this up from the Internet Archive, the Wayback Machine. And that's largely because Magnolia had a complete failure. Um, 1 January, they had a complete outage, and it took them about 3 weeks to realize that their user database was corrupted. And only in September of 2010, so it was a little over a year later, they confirmed that they were dead. They were trying very hard to recover the user data for more than a year. And maybe you don't remember Magnolia because right after that, Delicious is what won because Yahoo eventually acquired them. Delicious was Magnolia's largest competitor, I guess. So, you know, database failure actually caused a business to go well out of business. So what really happened? They were a Ruby on Rails application. They had 4 self-hosted Mac Minis. They had a couple of Xserves. So as you can tell, Apple doesn't make Xserves anymore. And they only had a 500 gigabyte plus MySQL 5 database. We don't know if they use InnoDB or MyISAM, but since it was MySQL 5 and we have such catastrophic failure, we would go with the fact that they were probably using MyISAM back then. Their failure started because they had some file system corruption. They were running OS 10, and that also led to corrupted database backup. And unfortunately for them, they were also using rsync for backup over the FireWire network. And rsync is great for static data, but database data is constantly changing. So this would probably not be a good way to back up your MySQL. Today, we would recommend you to use something like Percona Extra Backup and so forth. But generally never should you ever go and rsync your backups. So how would you do this today? Like, if you were going to set up a Magnolia, setting up backups today would probably make a lot of good sense. So for one, I guess you wouldn't go out there and buy a bunch of Mac minis. You would probably just deploy it in Amazon EC2 or some equivalent cloud, and you'd probably use things like EBS snapshots if you wanted to run MySQL manually. Otherwise, you could use Amazon's RDS, Relational Database Service, for MySQL, uh, and that would work just as well. And Amazon RDS has multiple engines available for you. So you don't only have to run MySQL versions, you could run, MariaDB Server and so forth, or even Aurora. You can also use multiple availability zones as well. So you don't even have to think much about doing stuff in terms of backups. You'll get Amazon to manage it all for you. But, I guess that would not make for as an interesting talk. And obviously, even if you use RDS, there are limitations that experienced DBAs will face. So we'll go down the self-hosted option, which is, you could also do this inside of a cloud service like EC2. So if you are doing self-hosted, I can highly recommend you to use Extra Backup. And Percona Extra Backup is extremely useful. It's integrated into Percona Server. It's very good for you to use with MySQL, even MariaDB Server. And when you use ExtraDB, the storage engine, you also get access to things like bitmap change page tracking and backup locks. So there are benefits to being self-hosted and also using Extra Backup. There is also the other interesting feature that you get inside of Percona Server, as well as MariaDB Server, is that you have this idea of using start transaction with consistent snapshot, which allows you to take full backups using MySQL dump, single transaction with master data, and actually use this to provision a new slave or get complete backups with everything as a transaction before it. So you don't have to run flush tables with read lock in this case. And this is, I would say, a highly useful thing as well. Today, you would also generally back up a replica. You probably not back up from the master. And I think the other very important feature that we have nowadays, since MySQL 5.6 and greater, is replication event checksums, where checksums are written to the binary and the relay logs, and they checked at various points. Errors detected, and when they are caused by memory or disk or network failures, sometimes even the database itself, you'll actually realize that replication will stop. Checksums can obviously be implemented either on a per slave basis, and of course turn on these options. Mismatches generally will give you a replication stop, and this is something you should totally use today. Now, Couchsurfing, fairly interesting website. They've been around for a long time, and they wrote a blog, but nowadays you obviously get, as I said, incident reports. Couchsurfing had a major avoidable hard drive crash, and it also turns out that the incremental backups weren't executed in a correct manner, and they lost data files. Couchsurfing, I would say, survived largely because Airbnb didn't come around till much later. What would have helped Couchsurfing would have been something like time-delayed replication, where MySQL 5.6 had this feature, which basically would allow you to have a replica that is delayed, say, by 2 hours or even 10 minutes. And you implement this on a per-slave level. It holds the execution of the SQL thread. So a replication delay on one slave user can configure multiple slaves to apply replication events immediately, another slave to apply them only after delay. So you really have a lot of deployment flexibility. But of course, during Couchsurfing's time, this was not something that was readily available, right? It was a feature suggestion in 2001. It got reported in 2006 as a bug. It only got pushed into a tree 2010, and it only became generally available in February 2013. It's also worth noting that MariaDB Server still does not have time-delayed replication. It has been pushed into the 10.2 tree, but 10.2 is still not a generally available release. So time delay replication exists in MySQL 5.6 and 5.7, Percona Server 5.6 and 5.7, but not inside of, say, MariaDB Server until 10.2 becomes GA. So even though the feature's been around since 2013, there's still a delay in getting it into a production server or a MariaDB server. So uh, it's worth noting that these features exist, but they're not equal across all MySQL distributions. So why replicate? There are multiple reasons to replicate, and the most common one is obviously to scale out. Uh, and a lot of people use this. They have masters and multiple slaves, and this is probably what many of you use as well. And there's also the other option of failover. You want master failover. When the master fails, a slave should take over and become the new master. And I put automatic there as well because you want to be able to do this automatically instead of just manually picking up operations. And you also want geographical redundancy across multiple data centers because sometimes data centers get flooded, sometimes they get burned because a fire breaks out and so forth. And there are multiple stories of people being inconvenienced when data centers fail. So replication across multiple data centers makes a lot of sense. And of course, the other thing is online schema changes. Online DDL can cause replication lag. Naturally, you'd use something like PT online schema change with non-blocking off the table. And we've seen multiple people out there write about how they use tools like PT online schema change in large-scale use cases, from the UK government digital service to TaskRabbit, Dubizzle, Wikipedia, Basecamp, 37 Signals, HelloSign, and so forth. And then multiple tools, obviously not just PT online schema change. Facebook popularized this with their OCS tool based on Oak Online Alter. And lately, one of the most popular ones I would say out there is GitHub's Ghost. And it's well worth taking a look at GitHub's Ghost for doing online schema changes. It's definitely probably going to be a tool of choice going forward. So in terms of replication, we have the default replication mode, which is asynchronous, which means that a master will get a transaction, it'll commit, a slave may or may not receive it, but that's not a problem either. And that's the default. It's extremely fast. Then you have semi-synchronous replication, which is a plugin. It's been around since 5.5, but it only became enhanced and lossless semi-synchronous in 5.7. So basically what happens is with normal semi-synchronous, you get the after commit message. So you commit to InnoDB is done before waiting for the ACK from a semi-sync slave. So committed rows are visible from applications even though semi-sync slaves may not have received the data yet. So if a master crashed and other slaves received the data is lost, but applications may have seen them. So you don't want the phantom read problem, and this is very problematic. So lossless semi-sync commits to InnoDB after getting an ACK from one of the semi-sync slaves. So when committed data is visible from applications, you are guaranteed that one of the semi-sync slaves has received it. So enhanced lossless semi-sync replication is a very good way to run in production and use things like automated failover together. Then there's also synchronous, fully synchronous replication, in where you don't have the concept of a master and a slave, but all nodes are equal. They have similar sets of data. Galera cluster is one of them, and we at Percona have Percona XDB cluster. Then there is group replication, or MySQL InnoDB cluster combined with a group replication that is, as I said, relatively newer than Galera. And there's of course NDB cluster, which is also a fully synchronous replication. And then there's a DRBD, the distributed replication block device. And this is where you have a master and a passive master. So it's sitting there doing nothing but consuming energy. And what this is commonly referred to as the RAID over Ethernet option. It is not something that you would have to use, I would say, today in 2017. But it is something that many people did use a lot in 2008, 2009, 2010, and so forth. And I think largely a lot of this is because now we have better replication built inside of MySQL that you don't really need to use DRBD. So there are multiple frameworks out there, and I'm going to talk to you about a bunch of them. But I like, of course, want to focus only on the ones that I think are worth for you checking out. There is MMM, and this is a tool that has been around for a long time. It's written in Perl, and it's recommended that you do not use this, generally speaking, um, because it's not it's not something that's easy to really put it out in production, and when it breaks, it can break fairly spectacularly. But if you have it working and it's not giving you problems, then by all means continue using it. There is several lines cluster control where you can set up a 4-node cluster in less than 5 minutes. It does replication, Galera, semi-synchronous, automated manual failovers, set up HAProxy as a load balancer. It works with hybrid environments or on-prem EC2, does workload simulations, hot backups, and so forth. Fortunately, this framework is not open source, so we'll move on. Then there's Orchestrator, and this one's the one I'm most excited about. It reads topologies, it has state, it does polling. You can modify topologies even via a GUI. It's obviously got a GUI and a JSON API. You can, visualize issues. You could kill long-running processes. It's an awesome piece of kit. It's so awesome that at Percona we decided that we should integrate it with Percona monitoring and management. So if you actually, take a look at the PMM demo and you type /orchestrator, you will actually be able to see this tool in action. And in fact, if you get on our beta trains, you will also be able to see this. So we really like Orchestrator, and Orchestrator is very very friendly license. It's Apache license. It's fully open source. It's being used in large scale deployments at places like Etsy, Booking.com, GitHub, and so forth. So we really think Orchestrator is awesome. Then we have MHA, and MHA does automatic failover. It's also again written in Perl, and it's been around again for a fairly long time. It's highly robust. Lots of people use it for automatic failover. But we're hoping to see more of MHA's features just get built in directly into Orchestrator, and that's where we think a lot of the future lies. Then there's also Tungsten Replicator, which was at one stage purchased by VMware and recently is spun out again. So this is a product that is going through a transition, but it handles it has a lot of features, replication features via its transactional history layer. And framework by itself that MySQL has implemented over time, but it still has some useful stuff like automatic failover and so forth. And there are also these 5-6 utilities, MySQL failover and replication admin, and you can get access to this from the MySQL utilities package. This does require the use of global transaction IDs that MySQL and Percona server support, but you are not able to use these utilities with something like MariaDB server. And there's a very good blog post out there by a company called Nylus, NYLAS, and they're an open source mail application. And they said, at one stage they were starting to use things like MySQL failover, where they use things like log slave updates, which were using lots more space, and then they migrated up to doing using other things. And it's a brilliant post about how people change their architecture over time. One of the cool things that MySQL failover handles is this idea of failback. Is that when a node has failed and gone out, but you've managed to restart, it actually rejoins as a slave automatically into the pool. So I find that to be extremely cool feature, and we'll hopefully see all of this inside baked into Orchestrator. There's also Percona Replication Manager. These are basically pacemaker agents. They're already included. They do shoot the other node in the head, stun it. And because, as I said, MariaDB server has a different global transaction ID compared to what you get in MySQL, there is also a replication manager for MariaDB. I would say this is also another tool for you. It's written in Go. It's very much something that MHA has learned a lot. It's taken a lot of learnings from MHA, and it's also available as open source, obviously. So GitHub. Let's talk about a scenario they've had. They were replacing DRBD with PRM and a pacemaker resource agent because they wanted efficient failovers. DRBD itself does not have the cold start, and no one likes cold buffer pools. So they were going to, sort of do replication prefetching with things like, to be fake changes and so forth. Then they realized they were getting poor performance, and that was leading to a high load, which would then lead to failing health checks, which would then trigger failover. So what was actually effectively happening was they were having failovers triggering failovers. And then something really odd happened in the sense that Pacemaker itself seg faulted, so nothing to do with MySQL. And then they realized they were getting data drift, so a lot of inconsistency between MySQL and other data stores. And they use Redis as well to query the dashboard event stream entries. And this failure, by the way, was several years ago, so it's not something new, but it's something you can learn a lot from. So they then concluded a while back that automated failover was the root cause of both downtime events. Now, this would then make you think, is automated failover a bad thing? And, you know, we should then think, because fully automated failover could be caused by false alarms. And false alarms are not nice because it causes a short downtime and it restarts all the write connections. It is also possible that you're getting repeated failovers. So again, kind of like what GitHub was encountering, right? Repeated failovers. And this could be sometimes caused by something like an overloaded master. So MHA, by default, does not allow a failover to happen within the last 8 hours, unless you set last failover min in the config file. So if a failover occurred within the last 8 hours, MHA will not allow that to happen. So it will actually inform you so that you don't have the false impression that automatic failover is going to happen. Then the other problem is data loss, right? A lot of people, they think that they maybe don't commit, they don't run sig bin log equals 1 or even InnoDB flash log a transaction commit equals 1. And then you need to wait for master to recover. But realistically now, in MySQL 5.6 onwards, and you have this idea of group commit in the binary log, and there's no reason for you to have sync bin log equals 0 and InnoDB flash log a transaction commit equals 0. You can turn all these on. And then, of course, split brain, right? So power off can take a long time, depending on what you're trying to power off. You definitely don't want to have your application writing to two masters. And this obviously is configurable. You sometimes use ITME tools, sometimes use Telnet, but you really want to shoot the other node in the head. So, is fully automated failover a good idea? I'd say yes, because today with the right frameworks, if you use things like Orchestrator, MHA, you should be able to do fully automated failovers with a 30-second SLA, and this is not unheard of. This is how large sites are run today, and if set up and configured properly, you should have zero problems doing this just as well. So now I'd like to talk to you a little bit about proxies, and there are many, many proxies out there. Proxies can help you assist with things like sharding. I'm going to talk to you at first about MariaDB MaxScale. Its most popular use is load balancing Galera clusters. It's a pluggable router. It has connection statement-based load balancing. You can use it for logging, writing to other databases, preventing SQL injections via filters. Also, it can route hints, query writes. It also has a binary log relay. It's a nice piece of kit, and right up until version 1.4, I can recommend that you even try looking at it. But version 2 doesn't use the GPL license, so it's not fully open source. You can, yes, see the source code, but no, you can't deploy it in production for more than 3 instances. So it has this thing called the business source license, and I think now it becomes less interesting for me because it is not open source. Then there's also the MySQL router, and MySQL router is extremely integral into giving you the MySQL InnoDB cluster abilities. So here you can manage MySQL farms. Of course, it requires global transaction IDs, and it's something that definitely has a very bright future for one to look at. And then there's Proxy SQL, which again is used alongside Galera clusters, but you don't only have to use it alongside Galera clusters. This is a high-performance proxy with a GPL license, so it's definitely becoming something you'd really want to look at compared to just MaxScale. It's built by DBAs for DBAs, It has query caching, query routing. It can do failover as well. It has. I like the fact that you can configure on the fly, so zero downtime. You can reconfigure stuff. It has application layer proxy. Of course, it works on it's Linux, FreeBSD, and so forth. It can have multiple interesting topologies. It also has a firewall, right? So if you have offending queries causing problems, you can act as a gatekeeper, reject them, and so forth. So it's actually a really nice piece of kit, and fully GPL. I think that's the most important thing as well. Uh, it is also included with Percona HDB Cluster 5.7, so if you get it, it is now nice and well integrated. There's also lots of bits about monitoring that it can also feed off the PMM, Percona Monitoring and Management. And again, it's worth noting that Nylas, which I mentioned earlier, is also a user. It's part of their very nice blog post. And I think the fact that it does persistent connections and query caching, you'll be surprised that this is a very performant proxy. It's used in production, and this is why we definitely like Proxy SQL as a solution and a choice. Now I'm going to talk to you rather quickly about sharding your data, and this is a picture of a durian. Sharding is the idea where not all of your data lives in one place. You can, hash records to partitions. You can partition alphabetically. You can put, end users to a shard. You can organize by something like a postal code, maybe. I think sharding is very interesting because it's easy to shard, but if you need to move content between shards or reshard after a failure, or the regular splitting of shards, this is actually why you actually need a framework really. So there is Spider. Spider is storage engine-based sharding using vertical partitioning for MySQL. It currently works with MySQL and MariaDB Server. It's been included in MariaDB Server for quite some time, but it's not a complete version. So you still obviously have to either recompile or get it from the Spider website itself, because it has more patches and features independently, especially when it comes to resharding. There is obviously Tungsten Replicator using the transactional history log. Use a JMX bean to handle sharding. And then there's obviously Tumblr's JetPens, which allows you to do things like cloning replicas, rebalancing shards, promoting masters, works in range-based sharding, and it also uses multi-source replication for aggregating to new nodes. And then there's one that I quite like a lot, and it's called Vitess. Written in Go, doesn't only work with MySQL, and obviously it works with MariaDB. This is what powers YouTube, for what it's worth. One of the cool things it does is the fact that MySQL connections, they require memory, right? Every time you make a connection, it's anywhere between 250 kilobytes of memory or up to 3 megabytes. Vitess actually uses very lightweight BSON connections. Everything is 32 kilobytes of RAM per connection, and it has connection pooling in Go as well. You can also rewrite SQL queries. So if you get a query that has no limit, it can be rewritten. It has range-based sharding, either horizontally or vertically. And it's extremely easy for you to use. So if you go to vitess.io and you want to run it with Kubernetes, you can get started in probably 10 minutes or something. If you run it manually, you have to obviously have it backed by something like etcd or Zookeeper so that your cluster view is always up to date, and it acts as a proxy for query routing. It's extremely interesting piece of kit, and fully open source, very friendly mailing list, so you can get help and so forth. And then we would like to talk to you a little bit about things like what has failed over time, right? So we've seen people say MySQL is horrible, so you got to migrate from it. Or but I think it's largely evolving, right? MySQL is like 22 years old, so you need to evolve. And Twitter has evolved over time, but really they've always ended up having MySQL as a good data store. And one of the good things that came out of Twitter that you can still use if you have to use Mesos, the data center so-called operating system. You can use something called Apache Cotton, and Apache Cotton can actually manage MySQL resources for you. And then we also see things like Dig. They started with MySQL, they migrated to Cassandra, and then they came back. And if you go and look at the old blog posts, the reasons why they were migrating is quite clear, that they maybe this could do with a re-indexing strategy and so forth to make things better. But Dig lost lots of users during this migration, and I think more people use something like Reddit now and so forth. Which then comes back to the last point that we want to talk about, which is around security. Uh, Security is very important. Many countries actually require you to have uh, security baked into your application. There are laws that make you want to have security, but otherwise, it's also just good to have security overall. So, the Philippines, they store voter data, and if you download this 330 gigabyte MySQL dump, it leaves 55 million Filipinos at risk because your email addresses are there, their passport numbers are there, and this data is just circulating on the internet now, and you can get it, and you could potentially ruin someone's life, and it's not cool. Uh, then the rather famous Ashley Madison data, the compressed dump is only under 7 gigabytes in size, and this one actually has names, street addresses, email addresses, phone numbers, credit card transactions of over 33 million accounts. Um, 36 million email addresses have been leaked, and that's a lot of people. And there were tools built like is my partner cheating on me kind of tools. So you could just enter your partner's email address to see if they had an Ashley Madison account. All this is like really uncool, and if you're doing stuff like this, you really want to make sure your data is protected. And then Patreon, right? I This one actually affected me personally. Like you can actually donate to people via Patreon, so you can support journalists who are writing and stuff. And they had a leak, and you can download the leak. 99 tables. You can see full MySQL dump. Very unpleasant as well. And I guess you probably all know about the Panama Papers as well. This was Mossack Fonseca, and thankfully this wasn't a MySQL problem. It was actually Oracle. You can download the data. It's 2.6 terabytes worth of data, and they came in via SQL injections basically, right? What they were running outdated versions of WordPress 4.1, Drupal 7.2.3, and Oracle's fork of HTTP, which allowed you to view directory listings by default. And this meant people had to resign from their jobs, prime ministers, and so forth. So corruption and having offshore bank accounts not a good idea. So multiple options again. MaxScale has a database firewall filter. It's configurable, so you do rule matching, either allow queries, block it, and so forth. You can also obviously log it. MySQL Enterprise Firewall costs money, but it also has an intrusion detection system, blocks SQL injections, traffic. You can also build a whitelist. It's fully transparent, so you either allow, block, or detect. And then there's obviously Proxy SQL, where offending queries to the database, be it SQL injection or selects and so forth, you act as a gatekeeper and between app and the DB. So this is again another opportunity for you to try a Proxy SQL. Encryption, very popular topic. Multiple ways to have encryption of your data. You can either think about column encryption in the app, where you encrypt individual column data from the application or the ORM. You can think of system-based encryption, but then direct access via SQL is now no longer possible. There's also column encryption via middleware. Things like MyDyamo, which wraps engines, or CryptDB, which uses client-server proxy. Then there's also the other option of using something like dmcrypt, full system encryption, which CPU overhead is the real problem, right? Because you retrieve the page to the buffer pool, then you need to decrypt inside there, and it's also same with log files. The idea behind creating encryption in both MariaDB server, which was donated by Google, and also MySQL 5.7. Is to make drive-by data exfiltration impossible. So the attacker not only has to see the data, and also have access to your internal key management systems, right? So MariaDB Server 10.1 has table or tablespace encryption. So you can either encrypt a table alone or tablespace encryption. The original design that comes from Google's patch only does tablespace encryption, not table encryption, because it's obviously more secure for you to just encrypt your entire in-DB tablespace. Design goal is obviously to encrypt all user data that touches disks, so that's everything for InnoDB and obviously HTTP. You don't want to have key management on the file system, because if you break in, you can steal the key. So, and obviously there's no key rotation that's supported. So the next option is to use something like Amazon's key management server, and there is a plugin inside of MariaDB that will allow you to connect to Amazon's KMS, and this will just require you to, give Amazon your credit card, and you can actually get this done fairly cheaply. Key management servers are generally not cheap, and one could write multiple plugins for this fairly quickly and/or easily. There are obviously some caveats where MySQL binlog needs work to work with the encrypted binlogs, as well as Galera's clusters Gcache is not encrypted. Good news is that MySQL 5.7 also has encryption, and it encrypts the entire InnoDB table space, so you must use InnoDB files per table. At the moment, logs are encrypted. Now, if you're using a Percona server with Percona XDB cluster 5.7, we obviously do encrypt as well. So it's well worth taking a look at encryption overall. And as for overheads, the overheads are extremely low to, I would say, for real world data, you may have less than 1%. Synthetic benchmarks show sometimes 3% loss and so forth. So it's not a huge deal. So we're actually almost coming towards the end of this. So in conclusion, I think it's obviously really important to learn from others. Always learn from other people. Today, you want to use semi-synchronous replication with failover solution, so you don't fail over too often. So this is really semi-sync as a plugin, and something like Orchestrator or MHA there. And Orchestrator, as I said, comes with PMM, so maybe well worth looking at. Make good backups. Use Percona Extra Backup. Use MyDumper. Test them. Save them. Also, don't forget that you want to make logical backups, so something like MySQL dump also makes a lot of sense. You definitely need to shard your data, so use a proven framework to shard, get a proxy involved. So yeah, complete backup sometimes with multi-sources can be required as well, and this is something you can do with MySQL as well today. Use MySQL dump and extra backup together, obviously, and I would say security is key. Prevent SQL injections, encrypt your data at rest. Don't let the bad guys get your stuff. And in 2016, we even saw a website that was around for 16 years, and they were a subscription-based website taken down because they had lost some of their backups, and they were starting to only provide updates via Facebook, which it's just not cool. PMM, Percona Monitoring and Management. I talked about this sometime, and here's a quick snapshot. But you can go and try this yourself, pmmdemo.percona.com, and if you go to /orchestrator after that, you can also check out Orchestrator. It has query analytics, significantly improved with Sparklines. It's got a metrics monitor. It's fully built on open source software with Prometheus and so forth. Percona, we aim to stand on the shoulders of giants, and we integrated it. And we distribute it, and we hope that you enjoy using it, obviously, because it is very easy to use software. And the most important thing is this is not something that we're hosting for you. It's something you can totally just install yourself inside Docker containers. So totally check out the demo. Another interesting thing to note is that we have this conference called Percona Live. So even if you are not in the Santa Clara area, I highly recommend you to think about making a trip out there. This April 24th to 27th, so the first day is tutorial day, and then after that we have a 3-day conference. It's not just MySQL content. We have a MongoDB track. We have open source database tracks. So there's some content for Postgres, SQL, Cassandra, time series databases, graph databases, as well as a RocksDB component. It's going to be very interesting. And Percona Live Europe Amsterdam sold out in 2016. This happened in October. And we obviously want to do the same for Percona Live 2017 in Santa Clara. So get your ticket at the most affordable prices now. There is an early bird discount. It ends 31 January, so you have a little over a week. And I believe if you enter the code WebinarPL, that's WEBMINARPL, you will get a 15% discount as well. And of course, we are fully open for sponsors as well. And with that, I'd like to say thank you for listening to me for the last 40 minutes. I'm open to questions in our Q&A session. I'm also open to answering questions via email. These slides will go out to you via Emily probably soon. Yeah, I'm totally open to questions in the chat, right?
Yes.
And I think about now I should stop showing my screen.
It doesn't matter. You can leave it on. Yeah, so go ahead and enter your questions down in the questions field down below. As a friendly reminder, if we do run over, I'll send any questions over to Colin and we'll do a follow-up blog entry. So with that said, Colin, our first question is, what's the recommended solution to load balance Amazon RDS read replicas for MySQL and RDS for different throughputs needs, as some read replica nodes will be used for reporting and other nodes? Will we need to respond very fast without locking or getting affected by reporting SQL queries and so on? Please.
So we may want to get a little bit more information about this, but in terms of read replica balancing, you could also use things like sometimes you may get away with using something like Route 53. Sometimes you may get away with using something like HAProxy or Proxy SQL. I need to know a little bit more about your actual situation because I don't actually see the question displayed here. So how about you send me an email and I will respond to it. Is that okay? Or we will write a blog post about it as well, yes.
Yeah, I think email or a blog post will work too. Because once
Yeah.
the blog post is
I need the
posted.
actual question. Yeah.
Okay, our next question is there any out of the box MySQL based solution for handling geo-distributed inactive clusters, and any other how-tos would be helpful?
Yeah, so geo-distributed replicas. So yeah, out-of-the-box solutions, NDB cluster or MySQL cluster definitely has been a tried and proven solution for maybe even a decade now, right? I'd also like to say Galera cluster. So Pergola HDB cluster, we definitely can deploy that across multiple geographies, and there are multiple ways to do that as well. So you can, the minimum of 3 nodes. You can not only have, say, 3 nodes, say, in Singapore, but you could also have 3 nodes sitting in North America and 3 nodes in Sydney, and you could, completely be distributed. You could also choose not to upload all the data in a fully synchronous manner. So you don't want to be fully synchronous across those 9 nodes. You could be fully synchronous in a data center, and it could write to one of the elected nodes in another data center. You could also choose asynchronous as part of that. So there's, Galera cluster definitely can do all of this for you. NDB cluster. Tungsten Replicator is also a framework that handles this pretty much out of the box. And there's obviously MySQL NDB cluster, which will definitely be something worth looking at for this solution as well. And it's likely that even this year, that kind of out-of-the-box kind of play would even be available in Orchestrator as well. So yeah, I've given you a few solutions that are already there, and one that could be used even with SemiSync soon. Yeah.
While still on the topic of Orchestrator, do you have any recommendations for setting up master failover?
Yeah, so that is something that is still being built into Orchestrator. So at the moment, I'd highly recommend for you to take a look at MHA. But that is that is definitely coming to Orchestrator. And Orchestrator, if you're searching, it started its life at GitHub. It's available at github.com/Outbrain Orchestrator, but this is now also being pushed to github.com GitHub Orchestrator. So it's actually become a GitHub project, and it's well worth taking a look at that.
And then a follow-up question to that.
Yeah, yeah, sure.
Does Orchestrator also have any limitations when using cloud servers?
Cloud servers. So, well, yeah, it shouldn't be limited per se. It makes use of sudo GTIDs. So even if your cloud server happens to disable GTIDs, that is actually okay. But I think to come back again to your comparisons to MHA and so on, it is definitely under development right now, and there is a pull request available. So it's failover remote SSH relay logs. If you're looking for the pull request on GitHub, it's pull request 48. And they're going to obviously have MHA-like behavior fully into Orchestrator, as I said, very soon. So just hang in there, and yeah, you should have not too many issues, I would say, using this even in the cloud, and even using this with things like proxy SQL.
Okay. Our next question is, what's the difference between Percona Extra Backup and InnoDB Backup PEX, and which one would you prefer?
Yeah, that's a very good question. It's Backup X and Percona Extra Backup, and the Backup X is a script that you get, and it's a PostScript wrapper for the Extra Backup C program itself. It's a patched version of the Oracle one. Now, we obviously include it, and so I think the question you want to ask is, what should you use extra backup, or should you use the enterprise backup that is available possibly? Um, and I would say yes, extra backup is obviously good for you to use. It's open source. Extra backup copies InnoDB data logs, but for table definitions and stuff, FRM files, MyZem data, and so on, then you start using the wrapper script, which is Backup X. However, how does will this compare to the MySQL Enterprise backup tool? We expect that this meets requirements for you, that you don't actually have to pay for the enterprise backup tool, and if you want things like a usable full backup, you definitely want to look at also having Backup X work with it. I think we document features quite well for this as well, so I think you shouldn't have a problem taking a look at what we have as documentation. But we obviously don't say, oh, it's good for us to use extra backup and not MySQL Enterprise backup. If you want to use that, we're also okay with that. But we do recommend, obviously, to use the Percona Extra Backup. We provide even recipes as well as how-to guides for you to deploy this. So again, take a look at the documentation. Only thing that I think is worth noting is that extra backups are tied to InnoDB versions. So if you are using MariaDB Server, you may have to use older versions of extra backup and not the most current releases, because they may have an older version of InnoDB. But I believe we document all of this relatively well. We have references for not only extra backup as well as Backup X. We like to also list our issues, limitations, and so forth. But definitely one thing for sure is we don't compare to enterprise backup. But I would say a lot of people use Percona Extra Backup, it may possibly be the most popular backup tool for hot backing up MySQL because it doesn't lock your database during backup, and it's completely open source. So I hope that kind of answers your question, or mostly answers it.
Um, our next question is, you mentioned Galera cluster. What's the difference between that versus the Percona Extra DB cluster?
Right. Very good question there. So Galera cluster is the upstream version of Percona XDB cluster. So Galera cluster has been around now for about 7 years, and it has spawned several distributions. One of them being MariaDB Server, which includes Galera cluster, as well as Percona XDB cluster, which uses MySQL. And this is Percona's distribution of Galera cluster, and it's fully compatible with MySQL Server and so forth. But I think the important thing is we include things like a strict mode. So the strict mode is quite useful because we won't allow you to run experimental or unsupported features or the features that we define as experimental or and so forth. So this is much better, I would say, than just stock release of Galera cluster. We also include proxy SQL. I think that's quite a unique feature out of the box, so you can do load balancing right out of the box. We obviously also include more monitoring bits that can tie in with PMM. So yeah, we think this is the better distribution of Galera cluster. So Galera cluster also obviously exists, as I said, upstream. So you go to galeracluster.com, you can also download it there. Uh, and of course, most importantly, we have Galera cluster available for on a MySQL 5.7 base as well. Whereas if you go to galeracluster.com, at the moment the 5.7 is still a beta. It is not GA yet. So if you want a stable release upstream, you only get it up to 5.5 or 5.6 MySQL. We are providing it against MySQL 5.7. So you get all the new benefits and features of MySQL 5.7. And those features are not little. I mean, you get things like multi-source replication. You get DB online buffer pool resize, so much better optimizer, improvements in increasing username size from 16 to 32 characters, lots more security improvements, the 5.7 performance schema, GIS functionality, the JSON stuff, so you get docstore native JSON type. So all this is stuff you get in PXE 5.7, which you don't see in just a regular Galera cluster release at the moment. When Galera cluster 5.7 comes out, you'll get it as well.
Okay. Let's see. I think this is our next question. Do you have any recommendations on database migration services? For example, if I want to go from one database to another, homogeneous versus heterogeneous, I've used AWS DMS and it looks like it's not good at all. So any recommendations you have?
Uh, well, if the Amazon one isn't good for you, I also suggest you go to their forums and tell them, hey, I think you could improve it. Uh, as for automated, database migration services, migrations are always tough because you're not just migrating the data, you're also migrating, applications that speak to the data because not everything uses an ORM. So, migrations are very case by case basis. Many consulting firms available, Percona being one of them, obviously. So we'd be, very happy to help you with your migrations. Uh, as for automated tools, as I said, they just it's hit and miss. And then it really depends. Like if you suddenly say, hey, I want to migrate from Oracle, how do you migrate from something like a heavy use of PLSQL to something else? So I would say always generally try to get some kind of consultants involved as opposed to a direct migration, so to speak. But tools are there, and they probably get you, sometimes 80, even 90% of the way, but they won't get you all of the way most of the time. So um, I don't have one recommendation per se. And there are also like other ways to sort of replicate data. So you could use something like Tungsten Replicator while you're migrating, and have it writing from MySQL to say MongoDB even, and vice versa, or MySQL to Oracle, and so Oracle to MySQL. And these are all like possibilities. But again, I don't think it's direct and straightforward and just extremely easy to use out of the box. So I don't have a straight recommendation. But again, if I'll offer you the other one, which is to email saying, hey, you have this in your database, and what is it, I don't know, because you could be using DB2 for example, and then anything I say would be very different, or you could be just using Oracle, and then there are tools even like iSpira and so forth. But it really depends on what you have. So I'll offer the email and I'll respond, and if it's deemed something that we would blog about, we'll probably blog about it too.
Our next question is, Percona server, when is 8.0 gonna come out?
Well, usually we follow MySQL development extremely closely. So MySQL 8.0 is not out yet as a GA. We presume it'll be out as a GA maybe by the third quarter of this year. We usually trail maybe 3 or 4 months behind it, sometimes even less, while we harden it up, port our features. So yeah, you could. So I'm not a seance, but possibly end of this year, maybe early next year. Uh, but we have already started looking at MySQL 8. We have freeze for it. So we are actively looking, and when there's something interesting, we would definitely make it happen. But in the meantime, we are still adding features to MySQL 5.6, Percona Server for MySQL 5.6, and Percona Server for MySQL 5.7. Good examples. The fact that we also have compression in 5.6, which I think is a relatively new feature. Compressed columns with dictionaries. So that only appeared a few months ago. We're also working on things like encryption and so forth. So we are not afraid to or have features available inside of existing releases, and we will follow 8 closely. And if history is anything to show for it, we'll be good within 3 to 4 months right after a release of 8.0.
Okay, well, that actually looks like that concludes all of our questions. Um, so I just wanted to say, thank you everybody for attending today's webinar, and thank you so much, Colin, for presenting today. A reminder, the recording and the slides will be sent to you within 48 hours or less. And please enjoy the rest of your day. Thank you so much, everybody.
Thank you, everybody.